Hello, my name is Peter Dalder from Atkins Realis. In this video, I will talk about the distribution types used in SAGIS-SIMCAT modeling, and in particular, the use of non-parametric files, or NPD files. We are now looking at the SIMCAT user manual. On this page, we see the types of distribution that can be applied in SIMCAT to simulate the input of a chemical to a reach. For type 0, constant values are added for the input. In type 1, values are sampled from a normal distribution. For type 2, they are sampled from a log-normal distribution. And for type 3, a log-normal distribution is applied with the shift parameter. Type 6 and 7 are similar to types 1 and 2, but in this case they apply to loads rather than concentrations. Types 4 and 5 apply non-parametric inputs for concentrations, and types 8 and 9 do the same for loads. Types 10 and 11 are defined by power functions for concentrations and loads. I will come on to these later. If non-parametric files are specified, the SAGIS-SIMCAT system creates a series of files in the same folder as the DAT file, and within these files is information on the distribution that is sampled by SIMCAT, one for each reach. The SIMCAT distributions that I have shown here can also be applied to other inputs such as those from point sources or for headwaters. So let's briefly look at the NPD files. There are two types. In one type, 1,000 values are specified in rank order, and SIMCAT samples from these when it does the simulation. In the other type, monthly values are specified for the mean, standard deviation, shift parameter, and correlation. In the first row, we have the distribution type, annual mean, standard deviation, shift parameter, and correlation. And then in the third row, we have the monthly deviation from the mean. And in the fourth row, we have the monthly deviation from the standard deviation, then the shift parameter, and then the correlation in the final row. The SAGIS-SIMCAT system creates these NPD files if this is specified by the user. To do so, we go into SIMCAT and then Global Control Settings. First, we select the chemical. We look at total phosphorus. In this example, a default NPD file has been specified for livestock inputs in the default NPD box. This default NPD file references a database in the SAGIS-SIMCAT system called standard NPDs, which we see here. In this database, we can specify a series of NPD files, and for each of them, there are 1,000 values with a mean of 1. When we use create SIMCAT file to create a new SIMCAT DAT file, as you have seen in previous videos, SAGIS-SIMCAT uses the default NPD to create a series of new NPD files for each reach or other input, in which the mean is modified based on the mean value for that input. New default NPD files can be added to this database. Just remember, the mean value has to be 1, and there have to be 1,000 values, and the name of the file needs to be specified in the file name column. This is the name referenced on the Global Control Settings form. Now we're going to look at setting up a monthly NPD file. Again, go into the Global Control Settings form and into the chemical. We'll look at total phosphorus again. We'll remove the NPD value and then click on monthly and then apply. An important point here is that this can only be done for those chemicals for which monthly inputs have been specified within the SAGIS databases. At present, this is only the case for total phosphorus and orthophosphate for the arable and livestock sectors, and in some models nitrate in these two sectors. When setting up the monthly NPD files, we also have to remember that this also needs to be set up on the Create SIMCAT file form. We then go into sector inputs options, and then within this apply monthly data section, we make sure the sectors to which we wish to apply monthly NPD files are ticked. If we do not do this, whilst ticking monthly sector on the Global Control Settings form, NPD files will be created, but they will be created incorrectly. The final option that I am going to show you for the distributions applied in SIMCAT are the power functions. To specify these, we first go into the Global Control Settings form as before, select total phosphorus again, remove the tick on monthly. There are three values that we now have to add: power A, power B, and power C. Power A is the power function. This defines how the concentrations change between the lowest and highest value. If the value is 1, there is a linear increase between the lowest and highest value. If the value is greater than 1, the values increase more rapidly towards the higher concentration end of the distribution. If it is below 1, it does the opposite. Power B is a baseline load or concentration expressed as a percentage of the mean, below which the values do not fall. An example might be the phosphorus inputs from a catchment. Part of those inputs are driven by rainfall, so vary as rain increases and there is more runoff. However, a smaller part of the load might be a baseline, for example, that comes from small point sources. And this will always be the same irrespective of rainfall and runoff. This can be seen as a baseline load or concentration. Power C is a percentile below which the values are 0. This might be used for an intermittent input. Remember to click on Apply to save the settings. To conclude the video, I'll just say a few words about why you might select different distributions to run in SIMCAT. The default setting in SIMCAT is to use a log normal distribution for inputs of concentrations and loads. Non-parametric inputs, as defined by either power functions or NPD files, are only used when a log normal distribution is not the best option. An example is phosphorus inputs from the catchment. These tend to occur during periods of high rainfall and high runoff, and are therefore strongly skewed towards high flow conditions. In this case, a non-parametric file or power function defines this better than a log normal distribution. Another example is a situation in which seasonality is very important, such as if there are pumped inputs to a reservoir that occur mainly in the winter. In this situation, it may be better to define the inputs to the river using monthly non-parametric files. Another example might be where flooding occurs to a surrounding wetland, which is the focus of the study, which occurs mainly during high flows. In this case, either monthly or non-monthly non-parametric files may be suitable. This now concludes the video. Remember that there is more information on these topics in both the SIMCAT user manual and the SAGIS user manual. Thank you for listening.